Hello everyone. Today in this cantilever beam we are going to draw the shear force and bending moment diagrams. In this beam we have uniformly distributed load for a distance of 2 meter from the fixed end, and then we have uniformly varying load which varies from 0 at the free end to 36 at a distance of 2 meter from the free end. Let us split the UDL and UVL by this line. By using this rule, we can find RA. RA is acting upwards, so it will be positive. The UDL and UVL are acting downwards, so both of them are negative. For both of them, the total load will be the area. First, let us take the rectangle. We know the area formula of a rectangle. Length into width. Here the length is 2 and the width is 36. So this is the area of the rectangle. Then let us take the triangle. We know the area formula of a triangle, half into BH. Here the breadth is 2 and the height is 36. So this is the area of the triangle. For RA, we will get 108 kilonewton. From the point A, we can take a moment about B and we can find MA. In this case, we have to follow right hand side rule. MA is acting in the anti-clockwise direction, so it will be negative. RA is acting in the clockwise direction, so it will be positive. And the distance is 4. The UDL and the UVL are acting in the anti-clockwise direction, so both of them will be negative. For both of them, we have to multiply the area with the centroid distance. This is the area for the rectangular portion. We know that for the rectangle, the centroid lies in the center. So the centroid will be 2 upon 2. But we are taking moment about B. So we have to add the remaining distance. The remaining distance is 2. Now let us take the triangular portion. The area we have already found. We have to find the centroid distance. For this triangle, the centroid about this point is 2 upon 3 into breadth. Here the breadth is 2. So 2 upon 3 into 2. For MA, we will get 168 kilonewton meter. Alternatively, we can take moment about A from B. In this case, we have to follow left hand side rule. The UVL and the UDL are acting in the clockwise direction, so both of them are negative. We know that with the area, we have to multiply the centroid distance. These are the areas. For the triangle, the centroid distance about the height is 1 upon 3 into breadth. Here the breadth is 2, so it will be 1 upon 3 into 2. But we are taking moment about A, so we have to add the remaining distance, which is 2. Let us take the rectangle. We know that for the rectangle, the centroid lies in the center. So here it will be 2 upon 2. In this way also, for MA, we will get 168 kilonewton meter. To find the shear force values at A and at C, we can use right hand side rule. Shear force at just left of A will be 0. At just right of A will be the reaction RA, which is acting upwards, so it will be positive. Let us find the shear force at C. RA is acting upwards, so it will be positive. The UDL is acting downwards, so it will be negative. For the UDL, we have to take the area. We know that area is 36 into 2. For the shear force at C, we will get 36 kilonewton. Using the left hand side rule, we can find the shear force at B, which is 0. Here you can see the shear force diagram. Using the right hand side rule, we can find the moment values at A and at C. The moment at just left of A will be 0 and at just right of A will be MA, which is acting in the anti-clockwise direction, so it will be negative. Let us find the moment at C. MA is acting in the anti-clockwise direction, so it will be negative. RA is acting in the clockwise direction, so it will be positive, and the distance is 2. The UDL is acting in the anti-clockwise direction, so it will be negative. For the UDL, we have to multiply the area with the centroid distance. For the moment at C, we will get minus 24 kilonewton meter. Alternatively, using the left hand side rule, we can find the moment at C. The UVL is acting in the clockwise direction, so it will be negative. We know that we have to multiply the area with the centroid distance. In this way also, we will get minus 24 kilonewton meter. We know that in the free end B, the moment will be 0. Here you can see the bending moment diagram. Now we are going to end this session. Thank you for watching this video.